Well, hello everybody at Misericordia University. I'm sorry I can't be there with you tonight. I would much rather be at physics lab with you guys than I would be at parent-teacher conference day until 8 o'clock at night, where no one visits me. And if they do, they don't have much to say. But anyway, that is part and parcel for being a high school teacher, I guess. Welcome tonight, tomorrow night actually, and you don't have to do this tomorrow night. You could do this anytime. So feel free if you have something to do tomorrow night. You want to take a Wednesday night off, do it over the weekend for all I care. It's short, it's fun. It's an it's a electric circuit simulation. So it is a simulation, and just like last week when we had the electric field, we're going to go ahead and do a simulation for electric circuits. So it's a nice little circuit lab, and we're going to continue with circuits for this week and next week. So what I would say to you is why don't we take a chance or take a moment and look at this together. I just walked in from school. I'm having a cup of coffee here, so don't mind me. Uh, when we make a circuit, we basically have to have three components. We have to have a voltage source, such as a battery. We can have batteries connected in series. We can have batteries connected in parallel. And if you don't know what those words mean, then we're going to learn about them over the next couple of minutes. And what we have to have is a conducting wire. Usually a copper wire would work. Other metallic wires work fine as well, but copper is a very good conductor. And we have to have what's called a load. A load can be a resistor. It can be, I don't know what that was all about. It can be a light bulb. And in our simulation, we're going to be looking at a light bulb or a simulation of a light bulb. So we have some, if you take a look here, I don't know if you can see what I'm doing here. Hopefully you can. We have these two rules for a circuit. Rule 1, a flow exists in a complete circuit from one terminal of the battery through the rest of the circuit and back to the other terminal of the battery. This flow will be called the electric current. A complete current consists entirely of elements that are conducting. And rule 2, for identical bulbs, the brightness can be used as an indicator of the amount of current flowing. And we're going to test those out. So if you go down and look at the lab itself, the first thing we're going to do is have a battery source. Our picture here actually shows two batteries connected in series. If you take a look here, once again, I don't know if you can see my cursor or not, but we have two batteries connected in a series, connected to two light bulbs, which are in a series. Now, a series just means like two people holding hands, just one hand. I'm holding hands with my wife. We're walking along. We're in series. Roller coaster cars are in series. Now, in parallel, those things would be like if you were holding each other's hands. Like if my wife and I decided to hold hands like this, right? And we would sort of be in parallel, I guess. I don't know. It's not a very good, not a very good analogy, I guess. But let's go ahead and pull up the simulation and see what we can do here. Okay, this is our interactive simulation, and we can look at the intro here. And looking at the intro, let's just take a look and see what we have. We have some batteries, and we can just slide them over, and we can connect them in series like so. All right. And if we wanted to, we could put a voltmeter across those to see what our voltage is. And just for kicks, let's see, 18 volts. So I have two 9-volt batteries. If we were to separate these, I don't know how to separate them here. Let's just put them back over here if we can. I don't know. I'm playing around with this a little bit here, just like you are. Yeah, well. Oh, we clipped them. Okay, so one battery, flip it around here. I don't know about you guys, but I have fun with this stuff. I know it's geeky. but what can you do? So I have one battery. I can see what the voltage is. It's 9 volts. So if I connect batteries in series, the voltages add. So let's say, for example, I just have my battery. I'm going to try to flip it around here so it looks straight. Doesn't have to be, but well, whatever. So I connect another battery. I'm going to do it in series. Now, this is kind of fun. You can have fun with this. You can connect your wires. Have a wire here, and I have a wire here. Now, it's interesting because really what's flowing in the wires in the metallic material is a sea of electrons. Electrons are negatively charged carriers, but by convention, and I'll show you what I mean in a moment, we say that positive charges are flowing. So let's say I have a resistor here, like so, and you can see we have a current flowing and the electrons are flowing in this direction. If I go conventional, it shows that the current is flowing from positive to negative. In that case, we can look at it that way. So I can go back and show the electrons flowing in the opposite direction. So this would be an example of a series circuit. Now let's see if I can figure out how to cut this. Let me see here. There should be a little thing that comes up. Let's cut that out. Let's cut that out. Get rid of my resistor and put it back here. And let's stick a light bulb in. Okay. Now you can add more wires if you want to. Let's say we want to put a wire here and we want to put a wire here. Oh my gosh, the batteries are on flame here. I have too much, I have too many volts here. So let me get rid of one of my batteries here. Let's cut that. Oh, you don't want to do that. So let me get rid of that. We don't want to short the circuit out here. So we'll get rid of that and we'll connect the wire here like so. Oops. Oh my gosh. Looks like, oh, wait a minute. See what I did here? I shorted myself out. Hang on. I've got everything connected to the same pole on the battery. Ah, good thing I showed you that. There's one pole and here's another pole. So there we go. Let me show you something fun. And I know this is getting long here. It's already 7 minutes, but let's get rid of the battery, or the light bulb rather. And let's just see what happens if we short the circuit. In other words, I don't have a load. Boom! My electric battery is gonna my battery's gonna catch on fire like an electric car. So let's get rid of that and let's put our light bulb back. And actually, let's go ahead and add our second battery. Well, I don't know how to do this. You'll play with it. Cut. There we go. Put our battery in. And now, if I do this right, it's kind of good that I showed you the mistake because it helps. Pull my light bulb back up. Oh, come on, light bulb. Well, I'll get a new light bulb. The heck with you. So there's one pole, and here's the other pole right there, the other connection. I did it again. You don't want to do that. Let's cut it. Get it up here and over here. And there we go. There's our beautiful light bulb, and the velocity with which the electrons are flowing is going to be the current. Now you're going to be hooking up light bulbs in series. I'm not going to do this all for you. You get a chance to do it yourself, and in combination. And just follow the schematic diagrams. That's all you have to do. Answer the questions. Have some fun with this. And then they ask you, they say, well, let's cut the circuit and let's put something else in here. We can have some other objects. Well, let's see what happens if I put a paper clip in. Is that going to be a conductor or an insulator? Well, it happens to be a conductor. Good. Let's get rid of that. Let's get rid of our paper clip here. And get rid of this. Get rid of the paper clip. And let's put something else in to see if it's a conductor or an insulator. Maybe you have some other things here. Eraser, pencil, wire, battery. There used to be a dog. Maybe they moved it because the PETA people got upset. But you could try putting other things in there to see what's a conductor, what's an insulator. I think you have a pretty good idea that a dollar bill, as worthless as it is these days, does not conduct electricity. Doesn't buy much either, but that's beside the point. The point is, have fun with this experiment, read through it. You have a week to accomplish it. I don't really care if you do it next Tuesday. Just have it turned into me by next Wednesday at lab time, and I will see you then.